Welcome to the Passivhaus podcast, brought to you by Passivhaus Accelerator, a catalyst for zero carbon building. For news, stories, and connections from all flavours of Passivhaus, check out the articles, videos, and more at passivhausaccelerator.com. Sign up to receive regular updates about events, join the community forum, and of course, attend the weekly online Global Passivhaus Happy Hour. Now, here's this week's Passivhaus podcast. Well, welcome back to another episode of the Passivhaus podcast. I'm Matthew Cutler-Welsh, coming to you from Auckland in New Zealand.
And I'm Zach Semke, coming to you from Seattle, Washington.
How's things in Seattle, Zach?
Things are good. I have been thinking a lot about the new infographics that we have on the Passivhaus Accelerator website. I want to let people know about them. So one of the big efforts that we did with the new website is create infographics to explain the benefits of Passivhaus and the Passivhaus design principles. And these are free for listeners to download and use. These are Creative Commons graphics that we're hoping will help folks with their storytelling and explaining about Passivhaus and all the great things it does.
I'm very excited about that because the number of times I see the classic 5 pictures from the Passivhaus Institute just get reused on websites or in PowerPoint presentations. We do at ProClimber, we provide some scholarships, and I've seen them so many times in applications for scholarships as a way of describing the principles of Passivhaus. So it's great to have some fresh content out there. And there's more than 5, right? You've gone more than just the classic 5 principles.
Yeah, people often talk about the 6th principle of Passivhaus, and there are many 6th principles, and we've chosen 5 of them. So we've given a total of 10. The infographic is structured so that the classic 5 are on the top of this circle, and the additional 5 are on the bottom. So the graphics that come from PHI and from VS and other organizations are also great resources. We're just adding some other ones, and they're kind of in black and white. So I think that for companies who are thinking about graphics that could mesh well with their overall branding, for example, like if you're an architecture firm, we're hoping that might make them easy to use. And so anyway.
So where can people find those?
Those are at passivhausaccelerator.com. And there is if you click on Passivhaus 101 at the top, the nav bar, you'll be taken there. And we actually have an easy to download folder of infographics with a little instructions about what the Creative Commons license means and attribution and stuff. So
great.
Yeah, we're excited.
It's great to have those. Thank you for that. And while we're thanking people, who else have we got to thank for the Passivhaus podcast?
Yeah, so our founding sponsors are 475 High Performance Building Supply, Baxtingui Architects, Mitsubishi Electric Train HVAC US, Partel, Glavel Foam Glass Gravel, Minotaur All-in-One HVAC and Dehumidification, RDH Building Science, Rockwool, Stocorp, and Zola Windows. And our champion sponsor is SIGA, and our stakeholder partner is NYSERDA, the New York State Energy Research and Development Authority. So thanks to all those sponsors for making the podcast and everything else we do at the Accelerator happen.
We are heading to the UK this week, and we've often talked about the fact that we like to keep things global, and sometimes it's a bit of a struggle for our UK and European friends to attend some of the weekly events. They do. We're very proud of the ones that do turn up because it's the middle of the night usually for them.
Yeah, it's impressive. It's great.
It's very impressive, and we love. I love it when I see people, even from we get the occasional visitor from Darmstadt and Germany on the the Passive House Happy Hour and Tech Tuesdays as well, which is awesome. But totally relevant as Passive House is, and there's some really great stuff happening over in the UK and in Europe, which we can all learn from. I'm particularly interested in these things called EPCs, or Energy Performance Certificates, partly because there's a lot of talk in Australia and New Zealand about introducing EPCs. And how would you describe an EPC, Zach, as in American terms?
Well, I think it would be the Energy Star rating would be the closest analogy in the US. Yeah.
So they're designed to be an indication of how energy efficient a building is going to be, and they're actually a requirement for anytime you buy and sell a house in the UK, or even just rent it out. It's required to have one of these certificates, and you get a certificate by someone coming in and having a look around and doing an assessment, and they do some calculations and they give it a score between A and G, depending on how, in theory, how energy efficient it is. There are some issues relating to that, which we delve into a little bit with our guest this week, who is John Palmer. Now, John is currently the Research and Policy Director at the Passivhaus Trust in the UK. Prior to that, he spent over 16 years in the Navy, for the Royal Navy, traveling around the world and being an engineer. So he is very used to science and engineering thinking. When he left the Navy, he translated that into the building sector and then soon discovered Passive House. He's a senior leader and, as I said, an engineer. He's got a proven track record of delivering complex projects in challenging circumstances, not least of which is his experience in the Royal Navy. But at a board level, he's had experience with delivering strategic issues and also communicating intellectual concepts such as Passive House. So it was a great pleasure to catch up with John. He did mention that he will be leaving the Passive House Trust soon, and he's moving into government, which is quite exciting because he'll continue to have some influence in this field from the inside, from some pretty serious decision makers in the UK. So a great person to connect with and to have on the show. I started out by asking John how he got into the building industry and a bit about his background in the Royal Navy. So, John, start a little bit about yourself before we get into Passive House. You've had a bit of an exciting background. Tell us a little bit about your time in the Navy.
Yeah, sure. So before I ended up in this world, I was in the Navy. I spent 16 years as a weapon engineer officer, which was great. You know, I saw various parts of the world. I got to do a variety of jobs, all sort of in all different spheres. Met some fantastic people and lifelong friends, and then decided it was time to go and do something different.
That seems a little bit different, a weapons engineer, than trying to make houses healthy and warm.
Yeah. So if you have a military career, certainly in the UK, what tends to happen is you either stay and do the full career and you leave in your mid 50s, at which point you end up you tend to stay in the defence sphere, or you can leave a little bit early and go and have the opportunity to go and do a second career. So that was my decision to leave a little bit earlier and to go and do something a bit different. And I'd always had an interest in buildings. My father ran his own electrical contracting business, so he used me as cheap labour for during my summers when I wasn't at school. So I kind of grew up on building sites, and I really had an interest in making buildings work better. And of course, the sustainable and low energy building movement was kind of just getting going really when I came out of the Navy, and so it was a good thing to get into. And of course, one of the things about being an engineer is that you've got a huge amount of transferable skill. So project management is project management, people management is people management, and if you can get your head around the technical subject, then everything else kind of transfers with you. So that's what I did.
So did you become a qualified builder, or did you do some training in the building industry?
So I did a little bit of training on various energy assessment methodologies, and how to do the UK standard assessment procedure for our energy performance certificates for domestic dwellings. I did that, and then I did a couple more energy related training courses, all of which the Navy paid for, by the way, which was great. They did a really good resettlement package, and then I ended up. Everybody said, "Oh, you need to try this Passivhaus thing," So I ended up gravitating towards Passivhaus and did the Passivhaus designer course. And it was at that point where all the sort of questions which I had remained unanswered from my previous courses, where they just kind of say, "Oh, you just you fill in this box and then you put the floor area in this box and then you click here." And I kept saying, "Yes, but why? And why does that? How does that work? And why?" And no one really knew the answer. It wasn't until I did the Passivhaus course that you get we get all the answers behind that, and you understand a bit of the building physics. So that all clicked, and then I ended up doing some freelance work, some project management work, and I went from there.
Just for some context, you mentioned EPCs, which I'd like to talk about because you've done a bit of work looking at the effectiveness of those for climate change and carbon emission transitions. But tell us a bit about SAP and EPCs and that whole sort of, if you can paint the picture for what's happening or what's happened to this point in the UK with regards to how labels get attached to houses.
Yeah. So it's a relatively complicated area, not because it's complex underneath. It's just misunderstood. So there's really three components which are separate but interact. The first component is SAP, which is the standard assessment procedure, and that's a building physics model. It's you can implement it if you've got enough time in a spreadsheet. It's got very similar characteristics to Passivhaus in terms of internal gains, losses, glazing, etc., and it's a procedure. It's a calculation methodology. So you put data into that, and it'll give you some answers out. That's the first building block, if you like. What you then also have is EPCs, energy performance certificates, and what they are a window on your SAP calculation. So they will provide some results from that SAP calculation, and those results are what the government chooses to put on the EPC form. The third component is Part L, which is our building code for energy, and Part L tells you how to use the SAP calculation to get a building to pass the code. Yeah,
right.
So those are the three separate components, and people tend to lump them all together, and they say, "Oh, EPCs are rubbish," or "SAP's rubbish," whatever. And actually, they're three separate things, and they all do what you ask them to do. So the SAP calculation, yes, it has its idiosyncrasies. It's not particularly good in some areas, but it does what it says on the tin, and it's actually not that bad in many circumstances. The EPC certificate was always designed to be an indication to the homeowner of how expensive their home will be to run, the cost of running their home in terms of energy. Mm-hmm. And that's what it does. But it's not very good at energy efficiency, and it's not particularly good at carbon either. And so as our world has shifted away from purely a focus on cost to climate change and carbon energy efficiency become really important, then it's less useful. And then finally, the Part L, the Part L, the code, the way that was developed was, we had this Kyoto Treaty, which was all based on reductions from 1990 levels. And until fairly recently, within the last 2 years, that's how much of the world has measured their targets. Is how are we doing compared to 1990? Because that was always the target. So that's what Part L does. That it looks at your percentage reduction on a 1990 baseline, and it presents the target in that manner. It also uses this thing, which I think many building codes do as well, called the notional building, which is it creates effectively a model of the building you're proposing to design, applies effectively the 1990 level fabric, and then applies the reduction on top of that. And the problem with that is that it doesn't encourage efficient design, because your notional building could be a single story, very bad form factor kind of building. But that again is where we were with how we dealt with buildings. So they all do their different things. They've all got the limitations, and what they all need really is a bit of an overhaul and a reevaluation of what they're intended to do and how they work with each other, in order to get us to a point where we are able to definitively say, right, this building is an efficient building, and it is net zero ready, whatever we define that to be, and it is appropriate for what the sort of thing we're trying to achieve on our journey to net zero.
You've done some interesting comparison looking at the underlying calculation, so the SAP calculation and PHPP. What did you find?
So we found that the core sort of engine, if you like, the building physics engine, is not too dissimilar and comes out with reasonable results in kind of a generic circumstance for maybe a typical non-passive house, but not too bad building, which proves the point that the building physics model itself is okay. But then as you introduce other elements, they all tend to diverge. So one thing is when SAP was put together, MVHR was pretty new technology, and even today you can design a really poor MVHR system, which is going to be pretty inefficient to run. So SAP has got some sort of built-in penalties or cautiousness, if you like, in there when it comes to MVHR, whereas, as we know, in PHP, MVHR is rewarded if it's done as it will be done properly. The other thing that you find is that the overall EPC rating, because it's this cost-based it's one number or one letter or grade. If you have if you have solar PV, for example, that will offset your electricity, which is in the UK a lot more expensive than gas, which means that your cost rating goes up. Whereas you actually, if you look underneath the surface, that's a relatively inefficient house with a big bunch of PV on the roof. So it gets a good rating because it's relatively cheap to run. Whereas in PHP, that would be nowhere near getting to the standard, because the fabric is not good enough. And as you know, PHP, from a fabric point of view, will ignore the effect of the PV.
So what's your recommendation to solve that if you were to implement a better system?
So I think there are a couple of really big things which make a significant difference. The first one is, why do we need an EPC with one number on it? We I don't know about you guys, but
because it's kind of an arbitrary number, right? It's a 1 to 100. It's not.
It's 1 to 100, and if you're at 100, your home costs nothing to run. Effectively, you have zero energy bill.
Right.
So that's that. That's the way it's skewed, and so what are the I was going to say. In the UK, if you pick up a sandwich or something in a supermarket, it doesn't just have one number on it for fat or calories or how good it is as a food.
Yep.
It has, and I'm sure you probably have a similar system, but it has fat, protein, carbohydrate, salt, whatever, and little red, yellow, green markers on it, because the consumer is intelligent enough to be able to say there isn't one number which is going to tell me if this food is a good food or a bad food. Yeah. So why can't we do the same on EPCs? So if you
and that's a really good point, because good is relative. If you're wanting to have a low sugar diet, but you're not too worried about fat, then one food might be good for you versus someone who's
Absolutely.
Trying to cut down on fat but is increasing the carbohydrate, whatever.
Absolutely. So the same is true for a building. So if you are a homeowner, for example, you are interested in cost. But if you're a government or a local authority, then you're actually interested in energy and you're interested in carbon and you want to know the efficiency of that building.
Mm-hmm.
So depending on who you are and what you're interested in, you would look at the right number and that would tell you. So that's the first big thing that would make a difference. And the second thing is this notional building. So the notional building technique is kind of dates back to the belief that if we did specify a definitive target for our energy use, and within that perhaps a space heating demand target, then that constrains freedom of design, and that would mean that architects would not have the freedom to create what they want to build, and so they would be unduly penalized and we'd just be building square boxes. Now we know that is not the case, because passive house buildings, even with their very low space heating demand, yes, you get rewarded if they are of a regular shape and a good form factor, but you can still make them other shapes and you just have to compensate. So it's perfectly acceptable. And if we had a space heating demand which is a little bit higher, then that's even more flexibility. So we know that we can design to specific targets. And we also know that it if we do that, it does drive efficiency of shape. And that's good, not just from a sort of energy use point of view. It's also good from an embodied energy point of view or an embodied emissions point of view, because more efficient shapes tend to have less form, less stuff. They're more efficient overall. So we know we can do that. And what that would allow us to do is be much more confident of where we are on our journey to net zero, because we can then say, well, if we are building to a space heating demand or even an overall energy use intensity figure of, I don't know, 30, 40 or 50 or whatever kilowatt hours per meter squared per year for our new buildings, and we're building X many thousand square feet of these buildings every year, then we know exactly how much energy we're going to be using in those buildings moving forward, and therefore we can turn that into carbon and we can see how we're progressing. Whereas the notional building technique, I could build a house which is using 80 kilowatt hours per meter squared per year, or I could build a house which is using 40 kilowatt hours per meter squared per year. Both those houses could potentially get an EPC grade A, but their actual energy use is completely different because of this concept of the notional building.
Right. And the notional building is a sort of a hypothetical model. Is that right? That's placed in a certain location and
yeah. So it shares the geometric characteristics of your design that you've input into the system. So if you design a really large single-story building with lots of glazing, that's the starting point. That's the notional building. And then what the standard is trying to achieve is a reduction on that, as opposed to saying you just need to build an efficient building.
Right. So it lets you start from a bad place and say how much can you improve something bad, and that's the measure of how good it is, as opposed to just having a straight performance target.
Correct. So a 90% improvement sounds really good, but a 90% improvement on something that's really bad to start with is may not be as good as a 50% improvement on something which is really efficient to start with. So that's the problem.
Yeah, and look, I don't think that's unique to the UK. This concept of notional design is common to other building codes. What's the level, like if you went out and asked the average person on the street, would some people in the UK have heard of Passivhaus? What's the level of awareness?
I reckon fair few would. Very few would know what it actually meant, but I think quite a few
German
people
thing over.
Yeah, they might not know it's German. It's just I think they would possibly, a lot of people would just think it's a generic term for a low energy building.
Right,
that would be it. So not widespread, but a few people.
And does everyone know what an EPC is?
Anybody who's bought or rented a house will, because it's mandatory. So again, I'd say maybe 50% of the population would know about an EPC.
Right. But so just on that point, is it mandatory to get an EPC if you're renting out a house as well?
Yes, and it is also mandatory for the EPC to be of a minimum band. So you have to hit a minimum standard to be able to rent that property out, and that's a relatively recent change.
And do they have to be updated? Do they expire?
Again, they do now. They didn't have an expiry on them, but they have now changed the regulation slightly such that they do have an expiry date. So you have to renew them if you want to rent and they've expired. And I can't remember off the top of my head how long that is. And
presumably in that calculation, there's an assumption of the internal temperature, is there?
Yes. So again, differences between SAP and not SAP. Differences between the EPC, the calculation that SAP does for the EPC, and a PHP calculation. Because the EPC is a regulatory mechanism, it standardizes some assumptions in the calculation. So the first thing it does is standardize the climate data. So it puts every single house in the same location in the middle of the country, so that if you build a house in Cornwall or you build the same house in Scotland, it gets the same EPC rating, which would seem fair, but the actual amount of energy use in those two places will be completely different. So it's designed entirely and understandably as a regulatory tool, but when people start using it as a design tool, then obviously it becomes increasingly inaccurate. So climate is one thing, and then the second thing is there are several things, but to answer your question, there is a standardized periodic heating pattern in there, which has the heating coming on at a certain time in the morning and on for a few hours and then off and then on again in the evening. And that can't be changed. So you have this fairly typical morning-evening usage pattern applied as well. And that's, again, is what the energy use is based on.
You touched on something really important there, the distinction between a design tool and a policy tool or a marketing mechanism. Do they need to be separate, do you think? Do we need tools that assist better design or incentivize better design, and then separate mechanisms for compliance or code, or for presenting to the market a distinction between what's good and what's not so good?
Yeah, I don't think the tools need to be separate, because the building physics model in SAP is a reasonable model, and the building physics model in PHP is a good model. They will do what you ask them to do. So if you are trying to do, you could do a regulatory calculation with PHP. You could put every building in the same climate place. You could standardize certain settings in PHP. So you could do exactly the same thing that's been done with SAP, and it will give you a certain answer. And if that's what you want, then you should be able to do that. But you should also then have the flexibility to flick a switch and say, right, I now don't want my regulatory answer. I want my actual answer. So put that building in its actual location, allow me to set an occupancy pattern, et cetera, et cetera, et cetera. Mm-hmm. And that will then give you a number which you could use in a different context. So that's what I think it is. It's being able to flip that switch and say, I now want to use these results for something different.
And why can't we just have the real result be the regulatory answer?
Well, there is an argument that we should be doing that, but should I just take the climate example? Should a building which is in Cornwall which is exactly the same as a building in Scotland, be rated differently in terms of its energy efficiency? So the building fabric is just as efficient in both cases, because it's the same building, same amount of insulation, same, so it's the same building, but the amount of energy use will be different. But the efficiency of the building is the same. So should it get the same rating? It could be argued that energy efficiency is not the right title for the rating. It should be an energy consumption or energy demand, in which case it would be different and correct. And the other point is, if you are testing for occupancy with, a grandmother who lives on her own in a 4-bedroom house in terms of heating patterns and et cetera, versus a family of 4 who are out all day, but have lots of showers. So again, the use actual energy usage is going to be very, very different, and you would want to know what that energy usage is going to be if you were trying to plan at scale and work out, what levels of energy efficiency we need to get down to and what our peak loads are going to be and all those kind of things that we need to go through in the future. You want to know that, but in terms of a rating for the building, that building could be sold and a different person lives in it and a different usage pattern.
Yeah.
So you actually need some level of consistency for the building, but then the ability to predict a more accurate actual energy use.
Yeah. So you've identified the sort of the fabric, the actual design of the house is one bunch of parameters, but then where you put it and the climate zone that it's in makes a big change to the heating load and the cooling load more and more.
Yep.
And then there's the usage and who's in it, how many people, and how they adjust the thermostat.
Yeah.
Which, coming back to the previous point, there's the design process for that, but then there's also figuring out the regulatory and the policy drivers for that. How influential do you think Passivhaus has been in directing policy up to this point, and going forward, do you think it's going to have some influence on the direction of housing policy?
Definitely, yes. I think the first influence it's had is that it's undoubtedly seen as the gold standard. So there is a reluctance for, I guess, a variety of reasons, but there is a reluctance for governments and even sort of government bodies or advisory bodies to recommend a named standard. So they'll shy away often from naming Passivhaus or naming a different standard, whatever it might be.
If they didn't come up with a name, it would be all right if they had named it.
Well, maybe, but actually, I think it's because it's it's not a government regulated scheme. It's a completely independent standard.
And something they don't have control of.
Yeah, they don't have control. It could change tomorrow. So they can't really be seen to endorse it as such. But what has happened is the magic number 15 pops up everywhere. So when governments talk about, or we've got a body called the UK Committee on Climate Change, which is effectively the government's independent watchdog on this, telling the government how they're doing and how they need to get to net zero. They will come up with reports, and in there they'll say, levels of fabric efficiency of 15 kilowatt hours per meter squared per year. Or even the government itself will say, we will aim for world-beating levels of fabric efficiency around 15 kilowatt hours per meter. So the magic 15, which effectively is Passivhaus, appears in lots of places, and that's no accident. 15 hasn't been picked by coincidence or analysis. It's because everybody knows that the best practice building standard that you can achieve is 15, and it's Passivhaus.
Yeah. Interesting. So where to from here? Where are things going in the UK as in terms of building regulations?
So it's interesting to look at where Passivhaus is making the greatest inroads, and an interesting way of analysing this is to look at what Passivhaus delivers for you, and then look at what those things, who might be interested in those things. So Passivhaus, obviously everybody listening is going to be familiar with this, but Passivhaus delivers you health and comfort benefits, lower energy bills. It gives you, it moves households out of fuel poverty. Whole life costs and whole life carbon obviously lower again. And it reduces your energy use at a national scale as well, which is something we need to be interested in. So it also can do things like improved cognition and performance, because if you were in an environment before which had high levels of CO2, for example, my school, when I was at school, I'm sure on a Friday afternoon, the CO2 levels were through the roof. If you're in a Passivhaus school, those CO2 levels are going to be controlled, and your ability to concentrate and think is going to be much, much better. And that's been, proven. So all those different effects. who finds that of interest? So the first thing is the health and the bills and the energy is a really great match for anything to do with social housing. So people who are interested in social housing, which might be local authorities or housing associations in this country, they are interested in the long-term benefit to their residents. And all those things are going to tick that box. So what a surprise. We're now seeing quite a lot of, hundreds of local authorities and housing associations building to passive house levels. So that's one kind of sector. You then look at...
I just have to point out that's quite incredible. I mean, it's because it smashes that paradigm of passive house being something for the wealthy. And it's still a gold standard, but it's not necessarily a gold standard of luxury and opulence.
Absolutely. These social homes they're lovely, but they're not opulent and they're not massive. They're just really nice, comfortable places to live.
They're fit for purpose.
So yeah, exactly. So we're seeing a lot of that. And of course, the other good thing is that if you're building at scale, so we all know if you build a one-off Grand Designs passive house, you could end up paying a lot extra money for that for a variety of reasons. If you're building developments in phases of 300 or 400 units, then you start to get the economies of scale, and the contractor becomes familiar with what passive house is, and many of those extra over costs which you would experience on a smaller build start to go down or even disappear. So the cost of the cost effectiveness is there as well.
Yeah.
So you've got social housing. Then the other sector is student accommodation, because again, universities are interested in the welfare, the costs to their students who haven't got much money, and also they're interested in this cognitive side as well. How does that affect? So again, we're seeing lots of developers, hundreds again, or even thousands of student accommodation units. And then you look at starting to look outside the sectors, schools. So we're seeing a bit of an explosion in passive house schools, because again, those factors, lower energy running costs is great for the school. Better CO2 levels and cognitive performance again is great for the school. So again, we're seeing those. So it's really quite interesting to track what passive house can deliver for different people, and then just see how those sectors are starting to accelerate and run away because it's doing what they want it to do.
And that was John Palmer, currently of the Passive House Trust. As I mentioned, John will be finishing up at the Trust soon, but still continuing to do very important work within the department that looks after building and housing as part of the government in UK. What were your outtakes from that chat, Zach?
Well, several. Great communicator, and so clear in the way he was able to describe these the three-letter acronyms of SAP and PCs. So that was great. He and I suspect that he will be a very effective proponent for the Magic 15 in his new
Magic 15
role. Right.
Yeah, we like 15.
Yeah, exactly. And
15 is 4.75. Is that right?
That's right. In the US, we say 4.75 kilobitu's per square foot per year. That's our analogous number.
I just love the fact that BTUs is British, and in Britain they use something completely different, and it's only in America that you use the British unit.
I know. It's I don't know why we didn't change that back in 1776. What happened?
I don't know. I know. Hey, and you've still got miles per gallon too.
We do indeed. Oh my, yeah. Don't even get started with units, please. It's just horrendous here.
So 15. 15 is the magic number. 15 kilowatt hours per square meter per annum.
Right. And so that was, of course, a very interesting theme. And I think we see it in a lot of places where passive house itself isn't necessarily becoming part of legislation or code, but the some key metrics of Passivhaus are finding their ways and into code. I mean, at the Policy Summit, Mike Fowler has talked about the success he's had with Washington State Energy Code advocacy, for example, around this, where he wasn't talking about Passivhaus, but the moves that the code made are all, or a lot of them were related to Passivhaus metrics. So that could be a really effective way to go. And who cares at the end of the day? I mean, not to be too glib about it, we need to figure out how to verify performance, and they're important questions to answer when you no longer are going with the certification. But if we're able to answer those and do it independently of certifications, then we're moving in a really important direction.
Yeah, well, I think this underlines the value of something like PHPP and those principles of Passivhaus, the process of designing, of thinking about the fabric first and the envelope of the building. And if you do have a model like PHPP, then you're calculating the stuff that really matters, which is how much energy is going to be required to maintain healthy conditions within a fairly narrow band for this building in this location. And that the number that you get out of that, whether it's 15 or 4.75 or something different, that's what matters. It's not some arbitrary letter on a certificate between A and G that you need to then translate to something, or a scale of 1 to 100, or even a star rating scheme. Those have a place for communication, and it comes to the point of scientists talking to scientists versus communication in the mainstream as well. And that's what a lot of EPCs are designed to do, is to be a sort of fairly blunt instrument to communicate in a mass market, which is useful, but we just need to be a little bit careful and not dumb things down too much where they become irrelevant or unuseful.
Right. Yeah, definitely. And he brought up the two issues that he saw with EPC, that, the ways that he wants to see that evolve. It sounded like one was not to solely be focused on the cost of energy as the measure, but also looking at the carbon implications of the energy performance. But the other one that I thought was really interesting, and something that is also an issue with code and with approaches like LEED, is the notional building problem, where when we talk about numbers like 4.75 or 15, we're talking about absolute actual performance, as opposed to some percentage better performance than this notional building. And as we were discussing before, like you could create some crazy, like maze shaped crenellated crazy form building,
which is a glass box,
right, made of glass, or whatever, but with tons of surface area compared to its volume, so really poorly performing building, and then and use that as your notional building, and then create a higher performance version of that building and score well in the EPC number potentially.
Because it's relatively better.
Right. But it misses one of the most important insights of Passivhaus design, which is efficient form, which has implications for the energy performance of the building, of course, as well as as was brought up in conversation, and as well as the embodied carbon implications of the building. So that was, I think, really insightful, and seems like the problem isn't necessarily the idea of coming up with a score. It's just, let's just make sure that we're honing it in on the things that we really care about today.
Yeah. A few things that come up for me. Firstly, is PHPP just keeps coming up as a really good tool, regardless, compared with other Yeah, sure. There's dynamic thermal modeling software that you can do, but just takes a long time, and it's just not going to be practical to do standalone private residential houses with a complex dynamic model all the time. But PHP just continually stands out to be a really good measure of these things that matter, and a design tool as well. And they have the ability to then have add-ons or be adapted to enable calculations for carbon. We have the ability to translate that 15 kilowatt hours or 4.75 into operational carbon if we know some of the conversions between what we're consuming and how that energy is generated, where it's coming from, whether it's fossil fuel or wind, solar, whatever, hydro. That's relatively easy. But more and more product suppliers are starting to offer EPDs, that's environmental performance declarations, as opposed to EPCs. And these enable us to look at the embodied carbon in those materials, which that embodied carbon is also site specific, because for us here in New Zealand, for example, we're a long way from pretty much everywhere, but particularly places like Europe. So we can bring in the most amazing high performance European windows that are going to make our building have really low operational energy, but we just need to account for all the manufacturing, processing, and then all the shipping to get that really nice window from a factory somewhere in Europe all the way to here in New Zealand. And PHP can enable that. So I think it all comes back to the strength of Passivhaus as being an enabler, not just for the design and construction, but also some of these calculations that are going to become more and more important.
Yeah, good point. And another thing that you brought up in the conversation that really resonated was that Passivhaus is a gold standard. It doesn't have to be the gold standard of opulence. And that leadership is really rapid uptake is happening in social housing, or in North America we call, or at least in the US we call affordable housing, because these organizations that are providing social housing or affordable housing are dedicated to the long-term health and welfare of their residents. And so they see those, the health and comfort benefits, the cognition benefits, all those benefits as really mission aligned. So we're seeing, that was exciting to hear about, that's uptake is happening so quickly in the UK among housing authorities and student accommodation and in schools, and it's good. It's good to hear. Yeah. And I think that's across Europe as well. We're seeing some amazing examples of lots of different typologies and building use types that are applying the Passivhaus. We excited the first Passivhaus hospital, which just is, when you think about that, it's kind of a no-brainer. Why aren't all hospitals places that are actually healthy inside? but that's a whole topic for another podcast. But it is exciting, and we need to, again, this is all about transferring knowledge from and experience from Europe to the rest of the world. They've had some great experience translating Passivhaus design into different typologies, including social housing, community housing, and we need more of that, because we're at that early adopter stage still here in Australia and New Zealand, where in the mass market Passivhaus is seen as a bit of a high-end brand. It's really only been applied to quite expensive individual standalone houses. That's changing. We've got some great examples of high quality but lower cost housing, and we certainly need more of that. And we need, there's so many firsts yet to be had down here. So lots of opportunity. Someone up for grabs: the first Passivhaus school, the first Passivhaus hotel, the first Passivhaus Airbnb, whatever. There's so many firsts that are still up for grabs down here. So get out there and stake your claim, architects. Indeed. Listening to you speak about this is like going back in time 10 years
Well,
in the Northwest. And not to say that we're actually 10 years ahead of where things are there.
Oh, but
I
you
don't
are.
know.
We're definitely a long way behind.
So, but that dynamic where the first Passive House projects are expensive houses, and the whole thing about first, like the first this, the first that, is we lived through that, and now the most we're there are multifamily buildings going up in Seattle, Passive House multifamily buildings going up in Seattle, and those are the notable projects. And Habitat for Humanities are involved in single family Passive House projects, and so it is. I think it's just part of the. I feel like it's part of the natural progression, maybe, where it starts. The early adopters are going to be the kind of one-off expensive, experiments, but that can change quickly.
And I just got to remind people that if you are working on any of those particular projects, then for whatever reason, then when you head along to site, pull out your phone, grab a video, and send it in, because we know a couple of hundred people who love watching those videos every week on the Passive House happy hour. Usually starts with a short video. And there are some great ones there. They don't have to be flash. Just pull out your video, get someone to walk around, show us what's going on out there. Other designers and builders love to see, particularly during the construction stage as well. So send your videos in.
Yeah, please do.
All right, what do we got coming up in the calendar, Zach?
Well, we'll have links to a bunch of stuff that's coming up for Passive House organizations around the world. This week at the Passive House Accelerator, we have construction tech. The episode on Tuesday will be with Reed Rowland, and he is going to be talking about the transition of a project from Energy Star up to Passive House and what that took. So kind of what that delta is, and some tips about moving to Passive House levels of performance. And then so that's Tuesday our time, Wednesday your time in New Zealand and Australia. And then on the next day, Wednesday for us, the happy hour will feature Kota Ueno, who is from Building Science Corp. And he's going to be talking about retrofits of interior insulation in masonry structures. So, and he calls it a low carbon retrofit case study. We're really looking forward to this. It's exciting to have an expert from Building Science Corp join us on the happy hour. So we hope people will come for that. And then on Thursday, May 20th, which is Friday, May 21st for you, we'll have Resilience in Canada. This is a joint event produced by Passive Buildings Canada, Passive House Canada, and Passive House Accelerator. And we'll feature 3 exciting projects in Canada that are harnessing the benefits and the durability and resilience and thermal benefits of Passive House to offer resilience for communities. So it's going to be about that connection between buildings and community and weathering the storms. So we hope you'll join us for that.
Lots going on as per usual. And don't forget to check out your local affiliate or Passive House group, wherever you are, for events activities. If you do want to post those, then let us know. But also there's almost too much to share in the world of education, events, activities. So check out all your local directories to see what's happening in your part of the world. I think that just about wraps it up for this week, Zach.
Yeah, this is great. Thanks for doing the interview. That was really interesting.
Oh, it was a pleasure. It was, like I say, always great to reach out and hear from our friends in Europe and the UK. So, thanks to John for his time as well. Really appreciate that. Thank you, everyone, for listening in, and check us out wherever you get your podcast. But make sure you share this, give us a rating and review if you get a chance. And we'll catch you next week on the Passive House podcast.